Hi there, today's lesson, A-level physics, projectile motion. So the objectives are to recall that when we deal with projectiles, we treat the vertical and horizontal components as separate entities, and to solve complex projectile motion questions. So what is projectile motion? It's where a body is moving in two dimensions, for example, a stone being thrown across a stretch of water, and it has both horizontal and vertical motion. And very importantly, the motion of the body in two such mutually perpendicular directions can be treated independently. And the bit I put in the box will make much more sense in a moment. So here's example 1. A stone is thrown horizontally at a speed of 6 meters per second from the top of a vertical cliff. If the stone falls vertically by 30 meters, calculate the time taken for the stone to reach the bottom of the cliff and the horizontal distance traveled by the stone, which we call the range. We're going to neglect the effective air resistance. And at A-level, that will always be the case. So let's move on. I'm going to show this example. So the mutually perpendicular directions is the vertical component and the horizontal component. We treat them independently, so they don't affect each other at all. So in this example, first of all, we need to find the time. I'm going to show you how to do this. So to find the time of flight, we need to know how long it takes to hit the floor. So taking down as positive, I'm going to do SUVAT and apply the equations of constant acceleration. So the vertical displacement is 30 meters. The initial vertical speed is 0, not 6. The 6 meters per second is the horizontal speed. Vertically, this is 0. Final speed, not interested. We could calculate it, but we don't need to. The acceleration is due to gravity, is 9.81 meters per second squared. And t equals time. So we need an equation without v in it. So the one we're going to use is S equals ut plus half at squared. And what you'll notice is that u is 0. So that cancels out. So we're simply left with S equals half at squared. We need to rearrange to find t. So t is equal to 2s over a square root. And then put our numbers in. So 2s is 60 divided by 9.81 for the acceleration. Square root will give us 2.47 seconds. So that's the time of flight. Now we can calculate the horizontal distance. So let's get rid of this. So now we need to work horizontally. So horizontally, taking right as positive, let's write SUVAT. So the horizontal distance S is what we're looking for. This is actually pretty simple, but I'm going to show you why. But this is the only time I'll do this. In future, I'll just do the simple way. The initial speed horizontally is 6 meters per second. The horizontal speed, just the nanosecond before this stone hits the ground, is still 6 meters per second. The acceleration is 0. There is no acceleration horizontally. There's no air resistance and gravity only acts vertically. The time we figured out is 2.47 seconds. Because the amount of time it takes the stone to fall is the amount of time that it takes that the stone is travelling horizontally for. So we could use S equals ut plus half at squared. But of course the acceleration is 0. So this goes to 0. So we're simply left with displacement is equal to speed times time. It'll be a recurring theme in these questions and should be a recurring theme in your examinations. So displacement is constant speed, which is 6, multiplied by the time that the stone is in the air for, 2.47 seconds. So simply S equals ut. If you put that in your calculator, you'll get 14.8 meters, which rounds to 15 meters to two significant figures. Okay, let's have a go at another one. Pause it if you wish to have a go, and then I'll take you through the answers. So we're going to repeat the previous example. It's the same technique. So down, positive. Let's do suva. So the vertical displacement is now 40 meters. The initial vertical speed is 0. Not interested. Acceleration due to gravity taking down as positive is 9.81 meters per second squared. And t equals t. That's what we're looking for. So same again, s equals ut plus half at squared. Of course, the initial speed is 0. So displacement is a half at squared. And then rearrange to get t. So it's 2s over a. Square root will give us the time. So 2 times s is 80, divided by acceleration 9.81. Square root will give us 2.86 seconds. 2.92 significant figures. Really, in your next calculation, you should use the full number in your calculator, which would be 2.855686246. You should just save that to make sure that there's no roundup errors. So now that we've got the time, we can work horizontally. So horizontally, remember, is constant speed. So we don't need the equations of constant acceleration because there's no acceleration. So it's simply s equals ut. So the initial horizontal speed is 20, multiplied by the amount of time that the stone is in the air for, which is 2.855 etc. seconds. I'll just write 2.86. But use the full number in my calculator to give 57 meters to 2 significant figures. Part B, how would these values be changed if air resistance was significant? There'd be a slight force acting upwards, so the stone would take longer to fall. And there would also be air resistance horizontally, so the range would be decreased. It's a common question that they tag on the end of exam questions, this one. But it's pretty straightforward. Okay, let's move on. Have a go at this one then. Just pause the video and then I'll take you through it. So let's have a look. A ball is thrown horizontally from the top of a tower, 45 meters high. The ball has horizontal velocity of 30 meters per second. Calculate how long it takes for the ball to hit the ground and the range. So essentially this is the same question, it's just more practice. So let's have a look. So down is positive. So let's write suva. So the displacement vertically is 45 meters. The initial speed vertically, again, is 0 meters per second because this ball has been thrown horizontally. Very fast, by the way. 30 meters per second is incredibly quick. Final velocity, not interested. The acceleration due to gravity is positive 9.81 meters per second squared. And the time taken t is what we're looking for. So once again, it's s equals ut plus half at squared. U is 0, so that simplifies to s equals half at squared, which we then rearrange to get time. So time is equal to 2s divided by a square root. So 2 times s is 90, divided by the acceleration of 9.81, and then square root, which will give us 3.0 seconds. So now that we have the time of flight, we can calculate the range, just like last time. So horizontally, there is no acceleration, so we can simply use s equals ut. So the initial speed horizontally is 30, multiplied by the time of 3 seconds, which gives us 90 meters for the range for B. Okay, let's move on. Example 2. So this one's a bit more complicated. There is a similar example after this. So if you've not done this type of question before, I can explain it to you. If you have done it or you think that you can do it, please have a go. Let's have a look. So we want the maximum height reached by the shell. So that means that we're working vertically. So I'm going to take up as positive this time because it's travelling upwards. So I'm going to write suva. So displacement s is what I'm looking for, the maximum height. The initial speed, now you have to be careful here not to use the 200 directly, because what we've got is a triangle essentially. So we've got this vector, 200 meters per second, and we want the vertical component. So the vertical component is opposite the angle. So if you watch the previous video, you'll know that that's sine of the angle multiplied by the magnitude. So the initial speed vertically is 200 sine theta. If you've not watched the previous video, you can use trigonometry. So the final velocity, the velocity at the maximum height vertically would be 0 because it's about to come back down, change direction. The acceleration is negative 9.81 because gravity is acting down and we've taken up as positive. T, I'm also going to write T, but we need to figure out T later. So initially we've got no time, so we need an equation without time. So the one that springs to mind is v squared is equal to u squared plus 2as. Then we just need to rearrange to find s. So that would be v squared take away u squared divided by 2a. If you put that in our calculator, that will give us s. So we've got 200 sine 30 squared, or minus 200 sine 30 squared, divided by minus 19.62, which is 2 lots of the acceleration. If you put that in your calculator, you'll get s, which is 510 meters. Okay, now we can look at the time of flight. So we're still taking up as positive. We do know the maximum height now, but you don't necessarily need to use it in a calculation. It's advisable not to use stuff that you've calculated if you can help it in case you get it wrong. Because in an examination, you would then get multiple parts wrong if you make, say, a calculator error. You might get a calculator carried forward error, but sometimes maybe not, depends on the question. So vertical displacement, I'll put 510, but I'll try not to use it. The initial speed vertically is the 200 sine 30, which you might have realised is just 100, because sine 30 is a half, and half of 200 is 100. The final speed vertically is 0 at the maximum height. Acceleration is minus 9.81 meters per second squared, and we're going to find the time of flight, t. So we can simply use v equals u plus at for this one, and then rearrange to find t. So t is equal to v minus u divided by a. So v minus u would be 0 minus 100, which is minus 100, divided by the acceleration minus 9.81, which gives us a time of 10.2 seconds. So it takes the ball 10.2 seconds to reach the maximum height, and very simply, for the amount of time it takes to come back down, is another 10.2 seconds. So once you get the time to reach the maximum height, you can just times it by 2 to give you the time of flight when something's exhibiting projectile motion. So 10.2 times 2 to give us the time of flight is simply 20.4 seconds. Okay, so let's just clear this to make some room. So now we want the range, so we're going to work horizontally, taking right as positive. So let's write suvat again. So horizontally is s. U is 200 cos 30. We want this component, which is adjacent to the angle, so it's 200 cos 30. Final velocity, again, just a reminder, is 200 cos 30. Acceleration 0. Time is the 20.4 seconds. So we just need to use s equals ut. Just a quick reminder there. So the initial speed horizontally is 200 cos 30. Multiplied by the time of flight, 20.4 seconds. If we put that in our calculator, we get 3,533 meters. Okay, hopefully that went okay. Let's move on. So this one, be very careful. So when you attempt this one, please draw a diagram at the beginning. And now I'll take you through the answer. So an arrow is fired upwards at an angle of 30 degrees from the vertical with an initial speed of 40 meters per second. So if I draw a diagram, if it's fired at 30 degrees from the vertical, then the vertical is here, and the arrow is fired like this. So that is 30 degrees. Sorry, that's not very clear. Let's try that again. So the initial vertical speed, if I make a triangle here, the vertical speed is actually, 40 meters per second. The vertical speed will be 40 times cos 30. So A is 40 times cos 30, which gives us 34.6 meters per second. And the horizontal speed is opposite the angle, so that would be 40 times sine 30. Which gives us 20 meters per second. Many students in the past over the years, when I give this question, they don't draw the diagram, so they get these the wrong way around. And if you get these the wrong way around, the rest of the question is defunct, it's just gone. So let's have a look at the next bit. The maximum height that the arrow will reach. So I'm just going to clear this. Just make sure that you've written down the two velocities. So maximum height. So let's take up as positive. Let's write suvat. So the displacement, which is what we're calculating, we'll call S. The initial speed, vertically, is the 34.6 meters per second. The final speed at the maximum height is obviously 0, as the arrow has stopped moving vertically and about to change direction. Acceleration is negative 9.81. The reason it's negative is because it's the opposite direction to which we took as positive. T, we can find out T later as well. So displacement is given by v squared equals u squared plus 2as, just like the previous example. So displacement will be v squared minus u squared divided by 2 times a. So v is 0, so it's minus 34.6 squared divided by minus 19.62. Negatives cancel. If we put that on our calculator, we get 61 meters. Okay, then let's figure out the time, how long the arrow is in the air for. So let's use v equals u plus at. So v minus u divided by the acceleration. So v minus u is minus 34.6 divided by minus 9.81. So that gives us a time to reach the maximum height of 3.53 seconds. So then to get the length of time that the arrow is actually in the air for, because that's the amount of time it takes to go up, and then it's got to come back down. So we need to double that answer. So let's times that by 2. So we get 7.05 seconds, total time of flight. 7.05 seconds. So we'll need that when we calculate the final displacement, which is the range. Let's do part E. So the arrow's final displacement, so we're looking at the horizontal range, so it's just S equals ut, because there's no acceleration, so we don't need the equations for constant acceleration. So there we go. The initial speed horizontally is the 20 meters per second. So 20 multiplied by the time of flight, 7.05 seconds. Gives us 141 meters. Okay, hopefully that's okay. Let's move on. So one more, an extension question. Can be a little bit tricky. So have I got this one? So just pause and then I'll take you through the question. So, a golfer drives a ball into the sea from a cliff of unknown height. The ball is struck at an initial velocity of 45 meters per second at an angle of 30 degrees from the horizontal. The total time of flight of the ball is 8 seconds. Calculate the height of the cliff. So this may seem pretty difficult. So you've got a cliff, you've got a golf ball that's then hit into the sea at a certain angle at a certain speed, and it's going to fall, and we want the height of the cliff. So you might be thinking, well, how do I do that? So you could calculate the time of flight to here, then calculate how long it takes to fall. But there is a more simple way. So let's have a look at what that is. So let's just write SUVA. We'll take up as positive. So SUVA. So the displacement S is what we're looking for, so I'll just call that S. The initial vertical speed, well, if we had this diagram, 45 meters per second at an angle of 30 degrees, the vertical one is opposite, so that's 45 sine 30. So 45 sine 30. Final speed, don't know. Acceleration, minus 9.81 meters per second squared. Time of flight, 8 seconds. So we simply just need an equation without v in it. So we can go with S equals ut plus half at squared. So the displacement would be ut, so that would be 45 sine 30, which is 22.5, multiplied by 8. So 22.5 times 8. Plus a half at squared. But obviously the acceleration is negative, so it's going to be minus a half times 9.81 times time squared, which is 8 squared, so times 64. And if you put that into your calculator, you will get an answer of minus 134 meters. So the negative just means that obviously we've taken up as positive, so the negative indicates that it will be minus 134 meters, so lower than where it started. So that must be the height of the cliff. Okay, I hope that's helped. Thank you for listening today, and take care.